Today we're going to learn about the vertex form of a quadratic equation. So there's some key pieces of vertex form. This a value right here controls whether it is up or flipped down. This h controls movement left or right, and changes in k control movement up or down. So quadratics can be written two ways. Standard form, which looks like ax squared plus bx plus c. This form is easier to factor, and you can quickly determine the y-intercept. It's typically just that c value. You can also write the exact same function and relation in vertex form. We like vertex form because you can quickly identify the vertex and it's easy to graph. So the vertex form parent function looks like this. It's y equals x squared. Or if I write that in basically expanded vertex form, where a, h, and k are replaced with numbers, we can see that we have an a of 1, an h of 0, and a k of 0. So whatever these numbers are, end up being our vertex. Oh, 0, 0. So we can see in our graph, wow, the vertex actually is at 0, 0. Now changes in these numbers change where our function is. What you'll see graphed already is our parent function with its vertex here at 0, 0. And now we're going to graph y equals 1 times x minus 2 squared plus 3. So this x minus 2 actually means I'm going to shift the vertex right 2. Shift right 2. And this plus 3 means shift up 3. So I'm going to take my vertex and shift it right 2, up 3. Right 2, up 3. So here's my new vertex. My new vertex is at 2, 3. I'm going to clean that up. So let's go ahead and graph the rest of the points. You're going to shift all of them right 2, up 3. Right 2, up 3. Right 2, up 3. Shift these points right here. Right 2, up 3. Right 2, up 3. And now we have our new shifted quadratic. It's exactly the same as the original one, except it's shifted right 2, up 3. Let's take a look at another one. Once again, in black, we have the parent function, and here we have an h of a k and our a value. So this actually tells me I'm going to shift left 4, down 2. And so if I'm shifting left 4, that means my vertex is now going to be -4, -2. So let's go ahead and plot that. I'm shifting left 4, down 2. Here's my new vertex. And let's move all the points over. Left 4, down 2. Left 4, down 2. So we can clean up our dotted lines because they were just there to help us count. And now we have our new function. It's exactly the same as the parent function. It's just shifted left 4, down 2. One last example. Now we have a change here in our a value. An a value of less than 0, so meaning a negative number, flips the graph upside down. And this x minus 3 tells me I'm going right 3. So I'm going to shift all the points to the right 3. 1, 2, 3. And then I'm going to shift these two to the right 3. 1, 2, 3. And then flip it. 1, 2, 3. And then flip it. 1, 2, 3. And then flip it. Same for this one. 1, 2, 3. And then flip it. And now I have my new function. It's exactly the same as the parent function, except it's flipped because of that negative a, and it went right 3. So in summary, a positive a, it opens up. A negative a, it opens down. If you see a x minus a number, that's a shift to the right because we had to plug in a positive number. If you see an x plus a number, that's a shift to the left. Think of that as x minus negative 2. Looking at this k value, a positive k is a shift up. A negative k is a shift down. And you can easily identify the vertex by looking at my h and k values.